Okay, so for today, we're going to take a little break from doing SOHCAHTOA and the unit circle, and I just wanted to review a topic in college algebra that's going to come up here in the next section. Our goal for today is to just review some radical simplification of radical expressions, and in particular, you might recall that you're not really ever allowed to leave a radical ever in the bottom of your rational expression. So our goal in today is to basically get rid of any radicals in the denominator. So officially it says to review our understanding of how to evaluate rational expressions, basically fractions, when they have radicals in the denominator. So how can you get rid of those? And I'm going to go ahead and give your nice substitute just a minute to press pause on the video, because I want you to take a moment to go ahead and finish up the warm-up. So after you guys finish the warm-up, she's going to go ahead and press play again and give you a minute to check your answers. If you finish early, you can always check with a neighbor, and hopefully these go well. We'll find out in a moment. Okay, so now you can go ahead and check yourself. Remember the key question you have to ask yourself for problems like 1, 2, and 3. You have to ask yourself, what is the largest perfect square factor that divides evenly into your radicand? So for number 1, I'm thinking a couple of you probably thought 9 times 8, 9 being the largest perfect square factor of 72, but indeed it's 36. 36 times 2 gives you 72. And then you root the 36 to get 6, square root of 2. That's a crazy irrational number, so we leave it as 6 root 2. Very similar for number 2, I broke it down into 25 times 2. The root of 25 is 5, and the square root of 2, again, is a crazy irrational decimal, so I leave that as 5 square roots of 2. Number 3, I broke it down into 100 times 2. The square root of 100 gives me the 10, and 10 square roots of 2 is my answer. For 4 and 5, very similar. Notice I was taking a radical and multiplying it times itself, essentially squaring the square root of 100. And we know that when we square a square root, the square root just goes away. So notice for number 4, you just get the value of the radicand, and that's 100. For number 5, the square root of 8 times the square root of 8 is the same as the square root of 8 squared, which means it's just 8. For number 6, we're going to mix it up a little bit. We have a fraction divided by a fraction. I just wanted to take a minute to remind you that when you when you divide a fraction into another fraction, you actually multiply by the reciprocal of the divisor. So you'll see I took this bottom number here, and I flipped it, and then I multiplied. So I took 1/2 times 4/3. You can multiply straight across to give you 4/6, which reduces to 2/3. Or you see up here that I did cross cancel out a common factor of 2. Okay, so that's your warm-up. Okay, and now on to our major mission. We have some vocabulary. The key term that I want you to recall from maybe your college algebra class is the term conjugate. You want to recall that it is an expression that we use to get rid of radicals in the denominator. And long story short, it consists of the same numbers in the original denominator, but different signs in between. So for instance, if I had you identify the conjugate of the square root of 3 plus the square root of 2, the conjugate of that is going to have the same numeric values, but a different sign in between them. So you'll see that it's the signs in between that are opposites. As another, for instance, if you have 2 plus the square root of 2, and you were tasked to identify the conjugate of that, it would be just 2 minus the square root of 2. So you'll see again, I gave you an example where we were given the same numeric values, but now we have the opposite signs in between. Okay, so let's get rid of these radicals in the denominator. Immediately, and you guys have done this a couple times, just even in this class before, if you see a radical in the bottom of a fraction, you know that that's a no-no. And what you're going to see in this first example is that there are no plus or minuses like there would be in example 2. In example 1, you just have a plain radical in the bottom of a fraction. And you might recall if we had something like 3 divided by the square root of 2, as in part A, you would need to multiply the top and bottom of that fraction by the square root of 2. Recall that this is essentially just 1. The square root of 2 divided by square root of 2 is just 1. So I'm not actually changing the numeric value of the rational expression. I'm just changing the form that it comes in. And when we multiply fractions, we multiply straight across. So I would take 3 times the square root of 2, and that's just 3 root 2. And then as we said in the warm-up, the square root of 2 times the square root of 2 is basically the square root of 2 squared. So that's just 2. Now, you only want to take this root if it's absolutely necessary. Case in point here, see the square root of 16 on the bottom? I wouldn't rationalize that. I would just make it 4. However, I do know that the square root of 640 can simplify. I see 64 hanging out in there. Do you? So I know that this guy's going to break down into the square root of 64 times the square root of 10. 64 times 10, after all, is 640. And this is still all over 4. Square root of 64, I know what that is. Square root of 64, that's just 8. Square root of 10 is an irrational number, and then this is over 4. Almost done. What I do happen to notice is that, I have 8 and I have 4. I can actually reduce that. 8 and 4 do reduce. They have common factors of 4. So I'll go ahead and take those out. Final answer to this guy, 2 square roots of 10. And I did just want to take a moment to remind you about the quotient property. These are some bigger numbers, and what I would first check to see is, well, do they reduce at all? So you can use your quotient property of radicals to sort of piece these back together. 972 divided by 486 is actually just 2 underneath the square root. So that's just another tool for you to use. Might make your life a little easier in the long run. Instead of breaking the radicals apart initially, you could just divide first also. So that would have also worked out for part B. You would have gotten the same response. True story. Okay, so now we have the messier problems to contend with. For instance, we have, and by all means, if this is going, this review is going too quickly for you, you can kindly ask the sub to press pause, and your nicest, most politest, if that's a word, way of asking. You're very nice people. I'm sure this is going swimmingly for all of you. All right, so in example 2, you're asked to simplify and write the expression with a rational denominator, a radical denominator. That's a little bit of a typo, huh? And you know what? I'm going to keep these problems relatively simple on your homework. So I'm going to go ahead and start with a problem that I actually tend to think is the easiest. And it's not necessarily, upon first glance, A, B, C is not too bad. But the big idea here is problems like part D. So I'm going to have you go a little bit out of order. I'd like you to take a look at part D, if you would. And what I see there is a minus sign in the bottom of that fraction. So I am going to do a little bit of work right now to get rid of that radical in the bottom of a fraction. And this is where the use of a conjugate comes in handy. So you're going to take 2 times the square root of 6 and add that to 7. Notice again we have our same numeric values, just the opposite signs in between. What to do to the bottom of a fraction, we must also do to the top. And now it's at this juncture you get 2 little mini math problems to work out. You have a little mini math problem in your numerator, and then you have a little mini math problem in your denominator. And if you look in the numerator, what we actually have there is 4 square roots of 7 times the quantity of 2 square roots of 6 plus 7. And I'm going to go ahead and use my distributive property. So I have to take 4 square roots of 7 times 2 square roots of 6. And then I have to add that to 4 square roots of 7 times 7. And I ask you to recall your product property. Remember, things that are outside the radical, you can multiply together. So 4 times 2 is something I can take care of. And things that are underneath the radical, you can also multiply together. So for instance, 7 times 6. And what I get when I multiply those together, 4 times 2 gives me 8. And then 7 times 6 gives me the square root of 42. And then I need to repeat this process for the next term. So things that are outside the radical, I can multiply together. However, things underneath, I have to multiply those together also. There is nothing else underneath the radical besides root 7. So I know root 7 is going to come along for the ride here. And then 4 times 7 is 28. So what I have on the top of the fraction is going to be 8 root 42 plus 28 root 7. And the square root of 42 doesn't simplify. So now what we have to go ahead and do is take care of the little mini math problem in the denominator. So in the denominator, we actually get 2 times the square root of 6 minus 7. So this quantity here times its conjugate, 2 square roots of 6 minus 7. And I'll follow my product property for radicals. If I take 2 root 6 times 2 root 6, that's basically 4 times the square root of 36. So if I do, here's me working out in my head. If I have 2 root 6 times 2 root 6 for my firsts in FOIL, I have 4 times the square root of 36. That's the same thing as 4 times 6. 4 times 6 is 24. So that's my firsts. And then I have my outers. Oops, that's supposed to be a plus there. Little copy error on my part. My outers is going to be 14 root 6 because 7 times 2 gives you 14. My inners is going to be negative 14 root 6. So as planned, my o's go away. And then my last is just going to be minus 7 times 7 because I have a negative times a positive. So my last is negative 49. So after all is said and done, I'm doing 24, take away 49 to simplify that denominator. You actually do get an answer of negative 25 on the bottom. So look, radical went away. No more radical on the bottom. Woo! So I'm going to go ahead and take what's in the numerator and write that down. And then I'm going to place that over my new denominator, negative 25. And that's in general the algorithm that you follow when you're trying to rationalize a denominator with a sum or a difference on the bottom. But remember, only use this when you have to. For instance, in part C, see that square root of 9 right there? That's just 3. So if it's easy and you can simplify first, do that. So this would be 3 minus 4 because the square root of 9 is just 3. Essentially, I have 25 over negative 1. This simplifies down to negative 25. And honestly, I said for your homework assignment tonight I was going to try to keep it easy for you. So I'm not going to have you worry about A and B. Your homework assignment for tonight is going to be the radical review worksheet, but you're only going to do certain problems. And on that worksheet, I did want you to take care of numbers 1 to 10. So you're going to have to flip it over, work on the back a little bit. And just 13 and 14 to bang the rust off of how to use a conjugate. But if you just can take care of those problems, maybe even before you leave today, you'll be in pretty good shape. When I come back tomorrow, we're going to start to talk about how do you find tangent, which is going to involve rationalizing a denominator from time to time. So I thought it was good to review this skill with you today. So we'll see you tomorrow.